Okay. Same, same thing will be there for you because now we don't have enough time. So it will be like that.
Okay.
Hello. 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 Hello.
Yeah, sir.
Okay.
So were you talking to
So
us? Sorry, sir.
yeah, I was trying to say hello so I could check.
Yeah.
So in this electrochemistry, as name suggests, it is the study of electricity, correct? Where we deal how chemical energy convert into electrical energy or electrical energy into chemical energy. If you want to understand these two things, you need to do electrochemistry. And why chemical energy? Because chemistry is about chemical. So when we do electrochemical, it means how chemical convert into electricity or electricity convert into chemical. And both are interchangeable into each other. Example, in case of galvanic cell, chemical energy convert into the electrical energy, correct? And in case of electrolytic cell, this will happen. So here you have electrolytic cell and here you have galvanic cell, correct? When we talk about this galvanic cell, another name of the same cell is the voltaic cell, a cell that convert into electrical energy. Okay. But more important is for your exam point of view, this is a spontaneous reaction. Samarth, what do you mean by spontaneous reaction?
Sir, once it is appropriately established, it happens on its own.
Okay. And Chinmay, what is the meaning of non-spontaneous reaction? Chinmay?
Sir, yeah, sir. Non-spontaneous means it requires input of energy, like
Yes.
continuous
So
input. Okay.
spontaneous is it if you provide the required amount of situation, then it will automatically proceed. Like activation energy you provide, it will naturally occur. But in case of electrolytic cell, you have to give external energy. And whenever you need extra effort, it means this is not a uh, like long-term feasible reaction. Correct? Long-term feasible reaction. Come to the conductor. You know what conductor is. What are the different type of conductors, Jimmy? Metallic conductor, metal R conductor, correct? And second is electrolytic converter or ionic conductor. Samarth, what is electrolytic or ionic conductor?
So where ions move to conduct electricity.
Yes. So in this situation, we have ion will be present in the aqueous solution or molten state. Aqueous solution, it means water. Just give me a minute. Hello. हाँ रवि बोल 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 क्लास में आना इधर हाँ ਕਹਿੰਦਾ ਕੀ ਹੋ ਗਿਆ ਤੂੰ ਖਾਏਗਾ होगा अग जाएगा खाओगा हाँ Uh, mm, man तो book करवाएंगे man तो book करवाएंगे तो क्लास लेना है था क्लास का बीच अरे तो मुद्दा की बात बता क्लास बात की है ठीक है तो कोई तो का होगा हम्म ना लीजिए हाँ ठीक हेलो guys am I audible
Yeah, sir.
yeah so in this electrolytic or ionic conductor because our chapter is related mostly with the ions like when ion move in aqueous solution in water or in molten state then there will be current and you know there are two type of electrolyte when we say electrolytic conductor so there are two type of electrolyte strong electrolyte and weak electrolyte and in this chapter we deal about this Chinmay, what is the strong and weak electrolyte
So strong electrolyte will dissociate completely, and weak electrolyte will dissociate partially.
and something in case of equilibrium which electrolyte do you use and in a
Yes.
equilibrium which
The weak
electrolyte do you use
electrolyte. Weak electrolyte.
why
The strong electrolyte will dissociate completely, sir.
so
Sir, so we'll get 100% products. We won't have an equilibrium state.
correct whenever there is a 100% breakdown so we will have complete product so there is no chances of the reversibility correct in case of
Yeah.
strong acid in salt in strong base we have the strong electrolyte so it can happen in the salt it can happen in the strong acid or strong base okay so these are the basic thing what are the weak electrolytes in me
So the substances which will not completely ionize or dissociate in aqueous solution.
okay and what are the example
Uh, so is water in a
CH3COH
then
amine is a weak base right ammonia amine and many more correct so in this chapter we will mostly talk about the electrolytic conductor because here there is electrolyte positive and negative ion so during this electrolytic conductor what will happen current will pass correct so tell me Samarth what is the charge carrier in this case
Sir, ions.
the
Free
ions
ions. Yes.
and what is the reason for the flow of electricity Chinmay?
because of the flow of ions, charge carriers.
Yes there are chemical changes occur at electrode cathode and anode and this is responsible for the current correct because ultimately we have to pass current and Samarth if you want to transfer the matter in which form it will take place if you want to transfer the material matter in which form it will take place
Sir,
ions form
aqueous. Okay.
ions form but in case of metallic conductor there is no transfer of material as such example when you pass current through the gold iron silver so there is no transfer of material as such correct what is the cause of resistance in case of electrolytic conductor what is the cause of resistance
I'm not sure.
interionic attraction if ion attract each other so they will create a hindrance because see if ion are free there is more passage of current but if ion are associated with each other then there will be more resistance correct And
Yes,
if there
sir.
is more viscosity, then there will be more resistance. Samarth, if you increase temperature, what will be the impact on the resistance?
Sir, it should reduce.
And what happens in the metallic conductor?
Sir, there it increases.
Why?
Not sure. So like unnecessary movement of electron happens more. So vibrations
What
in
is the unnecessary
among like
movement?
how do we then? So there'll be more
Kernel.
vibrations.
Kernel movement will happen. It will create the resistance in the movement of electron. Kernel, core part, right?
Yeah.
Kernel. Chinmay, do it follow Faraday's law? This electrolytic conductor.
Uh,
Faraday's
not
law. Yes, it does follow, and because in this chapter we have Faraday's law, right? To
yeah.
Faraday's law. So this is the basic introduction. What we're gonna do in this chapter. In this chapter, we'll talk about ions, free ions. These free ions are responsible for the chemical change at electrode, cathode, and anode, which is responsible for the current. Okay, and there is a material transfer. Why? Because you will see, like at one electrode, there will be the deposition of mass. At anode, there will be reduction in the mass, right? So there is a change in the material amount in the ionic form, correct? Like how zinc convert into zinc 2 positive ion, so there is a oxidation, copper undergo reduction, right? Example, if you have copper in the solution, this copper ion will convert into the copper. So more deposition of material at cathode, right? But zinc was present in the electrode. This zinc will convert into zinc 2 positive ion at anode. You will see zinc amount is decreasing and copper amount is increasing in the galvanic cell, right? Samarthi, you have seen, correct? How is that possible? Because of the matter transfer. And we'll talk about the resistance, cell constant, conductivity, and all stuff, right?
Yes, sir.
And Faraday's laws are two important laws for your exam.
Sir, and the
Yeah.
reduction potential, sir. I didn't understand.
Reduction potential.
Yes, sir.
Just give me a minute. So, reduction potential means how easily element can undergo reduction. Am I audible?
Yes, sir.
How easily element can undergo reduction. And to understand this, you have to compare the number. So if you know the table, you don't need exact number, but comparison. Okay.
Hmm.
Sir, and the current
You
passed here is AC, no, sir, not DC.
heard
The current passed through the electrolyte is AC, no, sir.
current passed through the electrolyte is a positive note, DC.
Is it DC, sir?
I guess I have read because in case of cell or battery, there is the DC current. Because in case of the current electricity chapter, which current you talk about? DC,
DC, yes, sir.
battery, right? DC. So, because whenever you use AC current, you use specific symbol like this. Example in AI, EMI, in AC, you must have seen this. And usually, in case of battery, when you see this, so then it means there is DC.
DC.
Okay. So this is the general rule because we have to continue supply the current. Come to your most favorite part, but one of the easiest part. Where you will face problem, let me know. First thing is electrolytic conductance. And now your real chapter start. When we say electrolytic conductance, it means how easily a material can pass the current. Electrolytic conductance. Correct? First thing you know in this is the resistance R. And what are the factors that decide R value? V and I. And Ohm's law is followed. I won't go much deep because you already know this, right?
Yeah.
Ohm's law.
Yes.
And here this unit of this will be ohm. This is similar like this. Correct? Here, second part is conductance, G. And when we talk about conductance, it is reciprocal of the resistance, conductance resistance. So opposite to the resistance. So G will be equal to 1 by R, reciprocal. Remember, I'm not saying uh, inversely proportional to. I'm saying reciprocal. Okay. So when you use this, what should be the unit Chinmay for conductance?
So conductance is ohm meter or Simon, sir?
No, either it is per ohm or Simon.
Yeah, sir, that's what. Yeah, per ohm,
Either it
sorry.
is
Yeah,
per ohm or Simon.
yeah, sir. Or mho
Right?
also we can. MHO.
Yeah, you can say more also instead of ohm, more. Then third thing is resistivity. When you say resistivity, another word we use for this is the specific resistance. You know about this in physics, correct? So we will not go much into the deeper section, but you know R directly proportional to the length, inversely proportional to the area. If you take constant, that is rho. Samath, what does it signify in this situation when we are saying R is equal to rho L by A?
So like if we increase the resistor's length, it will become more resistive.
Yes, it's simply, guys, like if you have to go from your home to your school, then it takes some effort. But if you have to go from your home to Mysore, then it will take more effort, more resistance, more problem. Correct?
Yeah, sir.
So resistance directly proportional to the length. Correct? And if you have to pass through the window or you pass through the door where it's difficult for you, window, less area, more resistance. But what I was asking Samad is what is the significance of this resistivity? It
So
signifies the nature of material.
yeah,
It also depends from which path you are going. Example, you
yes,
are going from your home to school. So distance is same, path is same, but in one way you are going through the main Pakka road, and in another way you are going through the Kacha road, right?
mm,
Muddy road. So resistance will be more in the muddy road, right? Everything else is same. So nature of material. If you take copper wire, silver wire, or gold wire or some other wire, then it will be decided by the nature of material. Correct?
mm,
So what will be the unit in this case, Chinmay?
1/0.
Ra by L. So it will be ohm meter.
Yes, sir.
Correct? Fourth is you have conductivity, or this conductivity is also known as specific conductance. What should be its value, Chinmay?
So specific conductance in terms of Simon per meter or what?
In terms of resistivity? It is
specific, sir,
this one,
R chi, 1 by rho. Yeah.
correct? Like how resistance is related to the conductance, same way resistivity is related to the conductivity. Understood? Reciprocal.
Yes.
And you can write in the other way also, because in this case, rho value is Ra by L. So Ra by L, correct? Can I write in this way also? Doesn't make difference, correct? 1 by R is equal to conductance, and L by A is also known as the
V star.
cell constant, correct? Understood? So I can write same thing in other form, 1 by rho, or G conductance into G star, it means cell constant. So Samarth, what should be the value of cell constant? L
Sir,
by
A
A.
by I.
Now tell me, Samarth, what should be the unit of kappa?
Sir, mo meter inverse.
Yes. So you can take per ohm and per meter,
Meter. Yes, sir.
or you can say Simon per meter
Hmm.
or mho per meter, right?
Yes, sir.
Because as you mentioned, Samarth, you will face issue in the unit in the later stage, not now. Correct? What should be the unit of cell constant, Chinmay?
Sir,
Per meter? Because length is meter, area is meter square.
per meter. Yes, sir. Per meter.
Now we are moving forward to the main things where you actually, how many things are? Four things are done. Fifth is the molar conductivity or molar conductance. This is where we are coming more toward the deep into the chapter, right? Molar conductivity. So, Chinmay, what is this? Give me a minute. Yes, yeah.
Sir,
I didn't
molar
send question
conductivity
of
is,
what?
yeah,
Yeah,
sir, it's conductance of all the ions,
sending.
like, which is produced in the solution, which contains 1 mole
Okay,
of electron.
sending. Sure. I'll listen. Actually, I'm taking class. I'll talk to you after the class and I'll send notes. Okay. So, yes, Chinmay, you said what
Yeah, so molar conductivity
conductance?
is conductance of
Hmm.
all the ions produced in entire solution
Uh,
with
conductance
1
of
mole of
all iron.
electrolyte. Yeah,
Because iron is responsible for the conductance or conductivity. And because we are saying molar, it means 1 mole in given volume.
yeah,
Or you can say conductance of all the ion by 1 molar solution, right? Easy to understand. If molarity is 1, what will be the conductivity from that is the conductance, correct? So if you calculate molar conductivity, it will be the kappa multiply by 1000 divided by the molarity. Okay, and now you will face real unit point. So kappa multiply by the, because what is kappa? Conductivity. Conductivity of 1 molar of solution correct? Conductivity of 1 molar of solution. That's why we are taking this. What will be the unit, Samarth, in this case? Unit of molar conductivity. What is the unit of kappa?
Ohm inverse meter.
Like Simon per meter.
Yes, sir.
If Simon per meter, here in the molar, what will be the unit?
Times
Mole
molarity.
per unit volume, meter cube.
Yes,
So
sir.
if you consider this, what will be the unit?
Sine
Can
meter
we
square per
say
mole. Simon
Simon
meter
meter
square.
square per mole?
More inverse. Yeah.
Per mole, because in molarity it is in the denominator. Any doubt?
Okay.
Okay. So remember this you will take 1000 when volume is given in liter. Okay. When volume is given in the liter. And related to this, you have equivalent conductance or equivalent conductivity. Chinmay, what will be this? No, you already told. Samath, equivalent conductivity.
The conductance, I think, in one equivalent of
One equivalent of
solution.
1 gram equivalent, right?
Okay. Yes, sir.
Same conductance, but for 1 gram equivalent for given volume. So for one normal solution, right? And in this one normal solution, you should have 1 gram equivalent in 1 liter of volume. Correct? Make sense? The same thing, equivalent conductivity will be kappa 1000 divided by normality. Make sense? Same thing exactly like the molar conductivity. Here you have normality. Chinmay, what will be the unit in this situation?
So we can take it as ohm inverse, meter
Correct?
square, and
Correct?
gram equivalent inverse.
Correct?
Yes.
And if you want to correlate normality with molarity, what will be the relation?
So normality is n factor into molarity.
Exactly. Here you will have molarity into n factor. Correct? Chinmay, do you know how to calculate this n factor, like n factor?
The basic formula in classes.
Yes. How to calculate this n factor for acid? How to calculate for base? And how to calculate for any molecule? Can we say in case of acid,
Mm,
you have to check basicity,
mm.
number of H positive ion. In case of base, acidity, number of OH negative ion. In case of any other molecule, if you don't have H positive or OH negative, then you will see number of electron transfer. Correct? How? Example, if you take zinc, here you don't have any acid or base, but you know zinc can convert into normal zinc, zinc 2 positive ion. So how many electrons are transported? 2.
2.
If if you have H2SO4, it's easy to understand because it can produce 2 H positive ion and sulfate 2 negative ion. So here basicity will be 2. Correct? If you have aluminium AlCl3, you know here aluminium is present in the form of aluminium 3 positive. So n value will be 3. And if you have MgOH2, this is base, can produce 2OH ion, so N value will be 2. Understood?
Yeah.
Okay. So this is how we calculate N factor, and these are like most common thing. Okay. But everything is theory if we don't solve question. Correct? Let's solve some question related to this and see how questions are asked. First question, resistance of one normal solution of salt is resistance 50 ohm. Okay. Calculate the equivalent conductance. Calculate the equivalent conductance of the solution if two platinum electrode in a solution are, if कुछ जल रहा है, if two platinum electrode are 2.1 centimeter apart and have area 4.2 centimeter square. Calculate. This is one of the most basic question. I'm moving to the next question. Solve it. Hmm. First question is done.
Yeah, sir.
What is the answer?
So the answer is uh sir, is it 10 Simon centimeter square per gram equivalent?
Samarth, what is your answer?
Sir, I got 1 by 50 Simons.
1 by 50 Simon.
Yes, sir. Conductance is asked, right?
What is equivalent conductance? Equivalent conductivity.
Oh, I calculated G, sir. Yeah.
What is this equivalent conductance? Here you can mention equivalent conductivity or equivalent conductance. And same way, if you have molar conductivity, means molar conductance. Yes, Chinmay, your answer was correct. Very good. So, what we are supposed to do, we know for equivalent conductivity, we have formula K 1000 by normality. We know normality is 1. It means we need kappa, correct? How to calculate kappa in this situation? You know kappa is equal to 1 by rho, and 1 by rho is equal to R A by L, correct? You have R value, you have L value, you have A value, correct? You can calculate, you will get answer. Once kappa is done, you can put values. Any doubt? I won't do full. This is more than sufficient. But answer was correct. Unit is important because unit in this case is Simon. Meter square or centimeter square, it's your choice. Per equivalent. Correct? We already said it here. Simon meter square per equivalent, and here same way 7 meter square per mole. Okay. What will be the answer of the second question?
Sir, I had a
Yes, Amat.
Sir, kappa don't we calculate in meter square in meters, sir?
Kappa you can calculate. What is the kappa value?
Sir, I got 1 for in terms of meters, sir.
You got answer. No, you told me the wrong unit. That is the thing. You told me Simon only.
No, sir. Kappa I'm talking about. I got kappa is 1.
You got kappa in the one. I wrote here in the centimeter form. You can convert.
Okay, in meter square it is 1, sir. Is 1 correct, sir?
Uh, Here, if you convert, see the thing is here. This is centimeter. This is centimeter square. So it will be per centimeter, correct? Then you have to convert into meter, and you know 1 meter is equal to 100 centimeter. So we got this per centimeter, right?
Yes, sir.
And if you convert into the meter, multiply with, you will divide with 100. Correct? So what will be the answer? Yeah, you are right.
Yeah.
But make sure you are right about the unit.
Yes, sir.
Yes, guys, tell me this answer. Correct? You can do the calculation part because unit is given in the centimeter. And if you calculate second thing, so this is given, you have to just compare the number. Same formula, right?
Yeah.
So which one will be more?
Second one.
First one, less molarity, more conductivity, right?
Yes, sir.
Exactly. That's all.
Mm.
Even you can do calculation for other part. So you can calculate kappa. Kappa is already given in first situation. In second, you know kappa is equal to 1 by rho. Correct. So kappa
Mm.
is equal to 1 by rho. That means 1 by 50. If you multiply this, it is it will be same. 2 into 10 raised to power minus 2. It means in both the situation, kappa is same. And if kappa is same, what will it depend upon? So which one will be more?
The one with less molarity first.
Exactly.
Yeah.
Any doubt?
No.
So we are done with the question of this part. What are the factors that affect the electrolytic conductance?
The temperature.
Temperature, correct? How?
Sir, when we increase the temperature, more dissociation occurs for weak electrolytes.
Correct?
So we get more ions that can conduct electricity.
So we know simply if temperature is increased, conductance will increase and resistance will decrease. Correct? For electrolytic conductor. Right? Chinmay, what is the second method? Second factor, if temperature increase, conductance increase. No, I will write symbol. Chinmay, second factor. Dilution. What is the impact of the dilution? Chinmay, if you dilute the solution, what will happen? Chinmay, are you there? Chinmay, I think you have some network issue. Samarth, you tell me. What is the impact of the dilution on the conductance?
Well, I think it should increase.
It should increase because if you dilute, then there will be more ion available for the dissociation and then it increases.
Sir, but we are being told that it increases by very small values. So like,
It depends which one are you taking. Example, in case of strong electrolyte, when you dilute, then interionic force will decrease. So breakdown is there, but very less. Correct. In
so
case of weak electrolyte with dilution, degree of freedom will increase, degree of dissociation will increase, right? So conductance increase. Correct. There is more dissociation, but number in case of strong electrolyte is less. What is the impact of dilution on specific conductance? Specific conductance means conductivity. What is the impact on the conductivity?
sir, it should
Increase or
increase because molarity is decreasing.
decrease? Why? When you increase volume, the number of molecule in per unit volume
Oh,
will decrease.
sir, conductivity is kappa, right?
Yes, conductivity is
Okay,
kappa.
okay. Yeah. Then.
So conductivity will decrease. Why? Because there will be less solute in per unit volume. Example, initially there were 10 particle in 1 liter. Now, if you dilute it, it become 2 liter. So what is the number of particle in each liter? In each liter, 5.
Yeah.
So number of particle in each liter reduce. Overall, it increase, like conductivity will increase, but sorry, conductance increase, but conductivity will reduce. Make sense?
Yes, sir.
What is the impact on the molar conductivity and equivalent conductivity?
Sir, I think that should increase because molarity is reducing.
Yes. So when volume is increasing, molarity is reducing, and when molarity is reducing, so molar or equivalent conductivity both will decrease. Sinma, do you have some network issue? Sinma is still having issue. Let me call him. Any doubt, Samarth, as of now?
No. Sir, graph also like.
Yeah, sir.
Sinma, are you facing network issue?
Yeah, sir. Some mic issues there. I'm fixing it, sir. I'll be back in 2 minutes.
Okay, because I'm trying to speak to you,
Yeah, sir. I
but was not getting answer.
the group also. some issue.
Yeah,
I'll
so,
talk 2 minutes.
okay, come fast. Yes, Amar.
Sir, the graph, sir, I needed that also.
Huh.
The dilution graph, sir, like I had a doubt of that.
Yeah, dilution graph, dilution graph or like how on dilution conductivity decrease.
Sir,
That's what you are asking.
where the strength is compared, like the weak and strong electrolyte is compared.
Yes, we will do that graph only now.
Yes, sir. Okay.
Okay. So, what is the impact of the interionic attraction?
Uh, it decreases.
It decreases. How? What decreases? Conductance.
Uh, yes, I think so. Yeah.
Why? Correct. Conductance will decrease, but why?
Sir, ions won't be able to move freely.
Exactly. When there is a more attraction, they won't move freely and connectivity will reduce. What is the impact of the polarity? Like if solvent have high dielectric constant, what will be the impact?
Sir, more conductive, more conductance.
How?
Sir,
High dielectric constant?
not. Sir, conductance and conductivity are inversely proportional all the time.
Conductance and conductivity are usually uh, opposite to each other. The reason being is because in conductance you just see the current. In conductivity, you see current per unit volume. That's the point. So in dielectric constant, what will happen? Ionization and conductance will be more when there is high dielectric constant, right?
Hmm.
That's the reason conductance will be, sorry, when dielectric constant increase, conductance will be more, not less. What is the impact of the viscosity?
That decreases conductance.
Why?
So I think movement of ions, I think so. Like viscous liquids are difficult to flow through.
Correct. Okay. If you understand this, now we want to understand what is the molar conductance at infinite dilution. Correct?
Yes, sir.
What is the molar conductance at infinite dilution? What is the meaning of that? Samarth, molar conductance at infinite dilution. When you have maximum dilution, then conductivity will be maximum. Correct? Conductivity will be maximum. So there is a special equation that is known as Debye-Huckel equation. Have you heard about this?
Um,
Debye-Huckel equation, which say that if you want to calculate molar conductivity at any point, it will be equal to molar conductivity at infinite because this is maximum. All ion are free in maximum dilution. If all ion are free, maximum conductance minus V under root C. Okay,
yeah, sir, I remember this.
minus B under root C. But remember, this is applicable only for the strong electrolyte. Only for strong electrolyte. Because in case of strong electrolyte, if you dilute, conductivity will increase but limited conductivity. What is the reason for conductivity increase? Only example, if you take a
Uh,
solid molecule and then you add water in it, then more ion will be free. Correct?
yes, sir.
But as such, there is no proper breakdown ki there was less breakdown, less degree of dissociation and now degree of dissociation increasing, right? That's why if you make graph, you were talking about graph. So if you increase concentration, what should be the impact on the conductivity?
Sir, it should reduce, like, according to.
Yes, because concentration means exactly opposite thing to the dilution. More dilution, less concentration. So what will happen? It will reduce like this, straight line graph. Because there is a limited change. That's why you won't see very drastic, correct? But in case of weak electrolyte, what will happen if you increase dilution? Increasing dilution means decreasing the concentration, correct? This is
Hmm.
for the strong electrolyte. But according to the graph, if you want to calculate for the weak electrolyte, what will happen? Initially, there will be change in the conductivity, but very less. And then it will increase drastically because more number of molecules will start dissociating. Make sense?
Okay. Yeah.
Okay. And here, because we know this is the concentration. What is the meaning of C? Concentration. B is the constant. And for a given electrolyte, it will be fixed value for a given electrolyte, right?
Hmm. Sir, and B root C is okay. Yeah.
And B is for a given electrolyte. For KCl, it could be different. MgCl2, it could be different.
Okay.
It depends upon the nature of material. But if you see the graph between the molar conductivity and concentration, as you can see, it is inversely proportional. Correct?
Hmm. For both the cases, sir.
Yeah,
Okay.
because minus sign. Na?
Yes, sir.
If you take do not consider sign, then it is directly proportional. Y is equal to mx plus c graph, right?
Yeah.
But how to calculate for the weak electrolyte? Because for strong electrolyte, it's the equation we have already here. What to do for the weak electrolyte?
Where we use equilibrium constant, I think.
We use equilibrium constant. Have you heard about Kohlrausch law?
Yeah, sir. College.
So can you hear me? No? Please switch it.
Chinmay, can you hear me?
Yeah, sir, I can hear you.
Your voice is not proper, Chinmay. Like you are speaking, I can hear, but not proper. What happened suddenly?
Sir, don't know, sir. Not sure. I could not hear what you are speaking.
Okay, but it look like are you speaking through earphone or headphone?
No, sir, nothing.
Samarth, how you perceive his voice? Is it normal for you or it's like only me?
Sir, before it was normal, sir. Now.
It, Chinmay, it look like it is coming from the distance. It like you are traveling in a plane and as a captain. Seriously. I'm not joking. It look like this. Like I can hear you, your voice is normal. It's just like it is coming from big mic.
I don't know, sir. I'm not sure.
Yeah,
Now
now
it's
it is perfect.
yeah.
No, it's fine,
What
sir.
happens?
Yeah.
Perfect.
I don't know, sir. What's the issue?
Okay. So Chinmay, tell me what is the Kohlrausch law of independent migration of ion?
Yeah, sir. So that law states that molar conductance of limiting molar conductivity of electrolyte is equal to the sum
Hmm.
of individual contribution of anion and cation.
Correct. So first thing is we apply this Kohlrausch law at infinite dilution. When you do it at infinite dilution, so there will be maximum conductivity, right? So at infinite dilution, there is already maximum dissociation of the ion. no further ion dissociation occur in this case. Then each ion will contribute toward the conductivity, whether cation or anion, each ion contribute in the conductivity. And if each ion contribute in the conductivity, what will happen? It does not depend upon the nature of the ion. Does not depend on nature of ion. It means whether you take magnesium ion or calcium ion, it does not depend. Understood? It depends upon the ion. Maybe +1, +2, +3 can make difference, but not their nature, chemical. Understood?
Sir, is
What is
this for
the
weak electrolytes on course?
yes? We use this for weak electrolyte because at infinite dilution, weak electrolyte will have the maximum molar conductivity.
Hmm.
So if
So
you
what do you mean by
calculate,
dissociation, sir? I didn't understand.
what do I mean by
Maximum dissociation.
maximum dissociation at infinite dilution? All the molecule will break down into positive and negative ion. So every molecule dissociate into ion if possible. And if there is a maximum number of ion, maximum current. So maximum
Okay.
dissociation means maximum current and maximum conductivity.
Okay, sir. Understood.
Okay? So at infinite, you have maximum conductivity. At any other point, conductivity will be less than that. So if you see like equivalent conductivity, what will be the value? Conductivity of cation and conductivity of anion at infinite dilution. This infinite means is infinite dilution. Understood? And based on the ion, you can do it because I have seen NCRT and NCRT explain it really well. Mm, NCRT electrochemistry. Conductance, we are done with. All these things are basically what are the factors that will decide the conductance, nature, number of valence electron, and temperature, right? If you increase temperature for what electrical conductance? Chinmay, what is electrical conductance? Normal matter.
Yeah, sir. Normal metal.
And normal metal
Movement
conductivity
of
will decrease as
yeah.
you increase temperature. Why? Why?
We can tell that no chemical change takes place, sir.
No chemical change takes place. Because kernel will hinder in the movement of electron, and that is
Yeah.
why there will be less conductivity here. So you know this. By the way, guys, this is also important from NCRT. Right? So we are already done for the strong electrolyte. For strong electrolyte, conductivity depend upon the concentration. C stands for the concentration. Okay.
Powering on.
If you increase concentration, conductivity decrease. Okay. What this A depend upon? What I said B, na? This is A. Constant depend upon the nature of the solvent, and it depend upon the temperature. It depend upon the nature of the material and temperature. How? Example, in case of these molecule, you have to calculate what is the charge on each. Okay, in case of Na positive, there is one positive charge, Cl negative one. That's why charge 1 1. In calcium, 2 positive, chlorine 1 negative. That's why 2 1. Magnesium 2 positive and sulfate 2 negative. That's why 2 2. Okay, so these electrolytes are named based on their charge. Okay, So that's why when I said B, na, it is same A value in this situation. Ditto same. Now, Kolark. Kolark examined a lot of the strong electrolytes. And he said, ki, okay, there is a regularity we can observe. But he gave independent migration law mostly for the weak electrolyte also. Both strong electrolyte, weak electrolyte, you can use this. Both for strong and weak electrolyte, you can use the polar law. See here how to calculate. Example, they are asking calculate the calcium chloride and magnesium sulfate conductivity. How to calculate? Calcium value is given in the table. What is the calcium value here? 190. What is the chloride value? This. Now, if you want to calculate calcium chloride conductivity, what will be the value, Samarth? What is the calcium value?
119, sir.
What is the chloride value?
Plus 2 into 76.3.
Why? Because you have two chlorine. That's what we said. What is the Kolark law? Kolark law say that key in the strong electrolyte example here, if you take, what will happen? Every ion will contribute in the conductivity. You have three ion, one calcium and two chlorine. Understood? Next, it is asking magnesium sulfate. Chinmay, what will be the value of magnesium sulfate? What is the magnesium value?
I'm not sure, sir.
Magnesium value is 106. Sulfate value is 160. What will be the answer? $266. Addition,
Yeah, sir, 266.
one magnesium, one sulfate. What we are trying to say through this Kolark law is simply iron are contributing for their conductivity. Magnesium ion contribution this, sulfate ion contribution this. Guys, this is free marks. It's just you are doing.
Addition, that's all.
Yeah. See, next question. Calculate this.
Sir, I had a doubt.
Yes. Shravan?
Sir, MgSO4 and CaCO2 are they strong electrolyte?
Yes, they are.
Sir, but then how are we using Kohlrausch law?
Because no, it is applicable for both strong electrolyte as well as weak electrolyte.
Okay,
We are
okay.
not saying it is exclusively used for the weak electrolyte. See here, using Kolark law of independent migration of ion, it is possible to calculate for any electrolyte,
Okay.
whether strong or weak. Moreover, for weak electrolyte like acetic acid, what will happen? It is possible to determine the its dissociation constant once we know this and this at a given concentration. So it is applicable for both. Understood?
Hmm.
So I actually you have confusion because I wrote. Did I write the weak electrolyte here?
No, sir, no, sir, no, sir. I only had asked back.
Okay. Even I was asking myself, "Hai, I wrote weak electrolyte, but I mentioned that it is applicable for weak electrolyte also.
Yeah, I wrote that.
Ah, so solve this question because guys, you can't imagine three-time NEET ask question ditto same uh, example in NEET, ditto same example with the same number. NEET always asks direct example of the NCRT. And trust me, for your CET, they gonna use direct the NCRT value. Remember this. Sometime if you remember na your data and all, like you solve 4 5 times, almost 60% question you can solve by just finishing all the NCRT question. 60% of CET question. This is so important. They will ask ditto number. So tell me answer. Should I explain this?
Yes.
So here you have sodium positive, chlorine negative ion, H positive, chlorine negative ion, and sodium positive, acetate negative ion. Correct? Ultimately, by adding or subtracting all these things, you have to get one hydrogen, ultimately result, and one AC. Correct? How we can do this? You need this and this. Can you take this in minus? So these two will be cancelled out. These two will be cancelled out. Tell me yes or no. Can you take NaCl in minus? So it will cancel out the sodium part and chloride part of other, and remaining thing in the reaction will be H positive and acetate negative, right? So how you will take? You will add these two and you will minus this. Yes or no, guys? Is it really difficult to understand?
No, sir. It's easy.
Okay. See, same thing. Here you will not understand in first instance what we are trying to say. You need ultimately only hydrogen and acetate. Everything you should remove. How to remove? Minus NaCl. Okay, this is very popular question. Solve this question. Conductivity of this acetic solution is this. Based on the unit, you can easily tell what we are talking about. Calculate dissociation constant. I didn't teach you dissociation constant, na? I'll finish the dissociation constant once.
Ah,
So in this case, we got to know for the strong electrolyte. Correct? This is what we are doing for the strong electrolyte, but you can do same thing for the weak electrolyte also. But you know what is the issue in the weak electrolyte? Samarth, 100% breakdown is not there, right?
yeah, sir.
So if 100% breakdown is not there, then one factor will come into the picture, that is degree of dissociation. Correct? What is the degree
Yeah.
of dissociation? Alpha.
Right.
Same thing given in the ionic equilibrium also. So what is the alpha value? What is the current equivalent conductivity? Divide by maximum
M not.
equivalent conductivity. If example maximum value is 100 and current value is 80, can you say simply 80% breakdown is there and still 20% are unionized form? Make sense?
Uh, so,
Based on the data we can compare, yes.
yeah.
Samarth?
So at infinite dilution, we'll have 100% dissociation. That's
Yes,
okay. Okay. Yeah.
approximately.
Okay. So yeah, then.
Approximately. Ideally, like theoretically it is possible. Practically, you know it is not. Correct?
Yeah.
Same thing you can take for the molar conductivity also. It depends whether equivalent conductivity is given or molar conductivity is given. Meaning it's same. Correct?
Yeah.
If example, maximum conductivity is 10 and current situation is 6, it means there is a 60% dissociation. Right?
Yeah,
This is
sir.
how you can calculate degree of dissociation. And how to calculate dissociation constant in this situation? Samarth.
So from here we can calculate, sir. Alpha
How?
square C. Alpha square
Huh,
into C is K.
correct. So dissociation constant, but remember you always calculate for the weak electrolyte. Why? Strong electrolyte is
It
already
has no.
100% broken down.
Indeed.
Yes, sir.
We are not bothered about them. What will happen? Dissociation constant. You did in the equilibrium again, 1 minus alpha.
Hmm.
When this is applied in every situation. But Chinmay, if degree of dissociation is very less than 5%, can you say ki it is very less? Alpha value is very less. So 1 minus
Yeah, sir.
alpha will be
We can
approximately
take
equal
it
to
as
1.
1. Yeah, sir. Yeah, sir. We can take it.
So can we say in that situation, Ka will be approximately equal to C alpha square?
Yeah, sir. We can take it.
Yeah, C alpha square, right? Though you can calculate solubility product also, but it will be too hectic for you. Okay, let's do question based on this so you can get idea what kind of question can be asked from the degree of dissociation. Dissociation constant of N-butyric acid is dissociation constant for N-butyric acid is 1.6 into 10 raised to power minus 5, and the molar conductivity at infinite dilution is 380 into 10 raised to power minus 4 Simon meter square per mole. Okay, specific conductance of 0.01 molar acid solution is. What will be your answer?
Sir, can we neglect 1 minus alpha?
1 minus alpha.
I got 0.4 is alpha, sir. So it is 40%,
Point.
right? 4 is alpha.
You got alpha value.
Yeah.
Yeah, you can ignore.
Sir, but it's
Sir,
40%.
alpha value is 0.4. Yeah, sir.
Alpha value is 0.4 or 0.04.
0.04, sir. 0.04.
Yeah, so it is 4%.
Yeah. Sorry.
If it is very low, you can ignore it. Do you feel you need to calculate specific conductance, right? So for this, you need molar conductivity, kappa into 1000 by molarity. Molarity is given, but it is not given in the centimeter scale. It is given in the meter scale, right? That is the issue. In this is in the if unit is Simon centimeter square per mole, correct? But it is given in the meter scale, so it will be kappa divided by mole divided by 1000. Because you know, if instead of centimeter cube in the volume, you use meter cube, what will happen? There will be 10 raised to power minus 6. Make
Yes,
sense?
sir.
That's why.
Sir, I got answers.
What is your answer?
Sir, I think so. It's 1.52 into 10 to the power minus 4.
You are close. What is your unit?
Sir, it should be Simon per. Sir, I calculated for centimeter. Simon per centimeter.
7 per centimeter. -4.
Yeah.
Yeah, it is correct then. Okay. And to make it even better, what will happen? You write like normal formula, 1000. But because instead of centimeter, it is given meter, so you will take this. Understood? Because in volume, instead of centimeter cube, you are using meter cube. Any doubt, guys?
No, sir.
So it means if you want to calculate this kappa, you should know what is the molarity. You have this, but you don't know what is the molar conductivity. How to calculate molar conductivity? Alpha is equal to molar conductivity and molar conductivity at infinite solution. This is also given at infinite dilution. This molar conductivity is given. Correct? It means we need what? If you want molar conductivity, you need alpha, and for alpha, this makes sense. Always go reciprocally. First, understand you need kappa. For kappa, you need molar conductivity. For molar conductivity, you need alpha, and for alpha, you can use this formula. Why? Because kappa value is given. Understood?
Yeah.
Because kappa value is given, and as you asked, here you can neglect 1 minus kappa because very small value. Any doubt, guys?
No, sir.
This is remember for the weak electrolytes. So this top segment is done where we are dealing with it. But remember, you have to solve question. In next class, you can ask any question related to this.
Okay, sir. Yeah.
Okay? See, until unless you don't solve at least 20-30 questions, you will never get idea whether you are good in it or bad in it. Okay? Second, most popular part where you will get Nernst equation is related to the electrode potential. Someone you were asking this point only, right? Electrode
Yeah.
potential.
Yeah. SRP. Okay.
Yeah. So standard reduction potential. So when we say ki electrode potential, it means it is the potential difference between the electrode and its ion. Right? It is the potential difference between metal and its ion. Any doubt? And when we say standard electrode potential, this is EP, electrode potential. Chinmay, what will be the standard electrode potential? There are three conditions. One, for 1 molar concentration at 1 bar pressure and 298 Kelvin temperature. If you have three conditions, 25 degrees Celsius temperature, 1 bar pressure, and 1 molar concentration, then potential will be standard. And usually you take it for the hydrogen, right? Standard electrode potential.
So
This
does
is
it also
standard.
depend on the nature of the electrode?
Standard electrode potential.
Sir, and nature of the ions?
Yeah, it does. It depends upon the nature of electrode. As of now, we are just saying ki what is the electrode potential? It is the
Standard
difference
electrode.
between the metal and iron. So it depends upon these two things. But
Yeah, sir,
what is the
understood.
standardized form of these two? These
Temperature should be 298 Kelvin. Molar concentration should be 1 bar pressure.
and that's why you will see many a time standard form is given. See, one is the electrode potential you calculate, and sometime you have seen this, right? What is this? Standard electrode potential, right? Correct?
Hmm.
Any doubt?
Yes. No, sir.
So here you have oxidation potential. What does it mean? A situation in which oxidation will occur. Oxidation potential. So what will happen? If you have any element A, it will convert into a positive ion and electron will be loose. Okay? This is oxidation. How do I know? Because there is an increase in the oxidation number, loss of electron, correct? Addition of oxygen, removal of hydrogen, correct? Reduction potential, how easily element can undergo reduction. Same redox chapter definition. Chinmay, what is the definition of reduction potential?
So definition of
Reduction. Gain of electron.
sir, I couldn't hear, sir.
Am I audible, Chinmay?
Yeah, sir. What question you're asking, sir? I couldn't hear.
My question was, what do you mean by reduction? Gain of
Sir,
electron,
in case of electrolysis, yeah, sir. Gain of electrons.
oxidation number decrease.
Yeah, sir.
Yes. Okay. So we know this thing. Now your question, Chinmay, as you ask, what are the factors that if I decide this electrode potential? No doubt, what should be the concentration of the solution, right? What is the nature of metal? Because concentration will tell you about the ion, right? And nature of metal, but pressure, temperature, condition also matter. That's why here we have standard, correct? So,
Yeah.
what are the factors that affect potential? So there are usually three. One is the nature of metal, second concentration, and third is the temperature, pressure. Concentration of the solution, nature of metal, which metal? Example, you know, uh, potential reduction potential of copper is more compared to the zinc. That's why copper can undergo reduction easily compared to zinc, right? And pressure, temperature, condition. That's why to make it better, we had a standard pressure, temperature, and concentration. So it will depend only on the nature of material. What is the reference electrode, Samarth?
Hydrogens.
Why?
I think sir, it separates two groups, negative and positive electrode potential.
Because value is zero.
That is
Electrode
also relative,
potential,
sir. But
yes, that is also relative. But again, we are comparing with any other element. Why only this standard? That's true.
Sir,
It is
because
relative
standard reduction potential is zero.
because standard electrode potential is zero. That's true. What else? Samarth, you are trying to say something?
sir,
Samarth.
I don't know, sir. Like beyond this.
No. But you had your opinion. Tell me.
Uh, So because
Tell
it's
me.
in water and it's like the most common electrolysis product.
It's in water and it is one of the most common electrolysis product. Uh, it could be one possibility, but
Sir,
not
SRP
the
value
main.
is it?
Yes, Sinwe.
Sir, SRP value is zero. It is assumed to be zero.
Yes, it is assumed to be zero. But what Samarth is saying is that this is again with like we are taking the comparison of other element.
Yeah,
What
sir.
is the main reason why only the standard? Even we can take oxygen as the standard.
Sir, I
because
think it has almost equal number of elements below it and above it, so like less than that and more than that to compare.
huh,
So like
it's
below
easy.
also,
Hmm.
yeah. So it's easy to keep it as a scale 0.
Yes, it's easy because it's available in multiple situations. So comparison become easy. So both factor contribute. What Chinmay said is key value is zero. Second, Samarth, what you mentioned key, it is available in the multiple situation. It is present in water also. It release is easy, and that's one. Understood. First thing, whenever we are taking reference electrode and we are calculating potential, we always take potential difference. Okay, we always take potential difference because you have to always compare. You can't calculate exact potential of one electrode. That's why you always take potential difference. Understood? You can accurately calculate potential difference, but not potential. You can't tell one person is good or bad, but you can compare with other person, can tell easily whether he or she is good or bad. Make sense?
Yes, sir.
Second, why hydrogen is used as the standard electrode potential? The simplest way is it can undergo oxidation and reduction both form easily. It can form positive ion as well as it can form negative ion easily, right?
Yeah, sir. Oh.
It can act as cathode as well as it can act as anode also, both simultaneously. It can act as cathode as well as it can act as anode. Example, when it act as anode, what is the meaning of anode? It depends which cell are we talking about, right? Whether it is electrolytic cell or electrochemical cell. In case of electrochemical cell, what is anode? Samarth,
Ah,
anode negative and cathode
yeah.
positive.
Sir, where oxidation occurs?
Yes, this is actually a good idea. Doesn't matter what is the charge, wherever oxidation occur, it is always anode. Where reduction occur, it is cathode. This is the better way to understand because you never do mistake if you know that. Wherever oxidation occur, anode. But in case of electrochemical cell, anode is negative. In electrolytic cell, anode is positive. Correct? So wherever oxidation occur, it is anode. Example in this case, hydrogen. If you take hydrogen gas, this hydrogen gas can release as positive ion and lose electron. What is happening in this case? Oxidation, right? What is happening in this case? Oxidation, and what Chinmay you mentioned. Wherever oxidation happen, it is anode. But at the same time, it can act as cathode. Cathode means where reduction happen, as positive ion can easily gain electron to electron and can become hydrogen gas again. Understood? Any doubt? So it can
No.
easily undergo oxidation and reduction both easily. Okay. Wherever oxidation occur, it is known as standard oxidation potential. Where reduction can happen, standard reduction potential. Okay. And arbitrarily, we are assuming for hydrogen, this oxidation potential or reduction potential is zero. Okay. Whether you take standard oxidation potential or standard reduction potential, it is zero. Why I wrote minus here? Why I wrote minus here?
Sir, the same potential applied in opposite direction will oxidize
Yes.
it.
If you are like if an element is undergoing oxidation, the reduction potential will be in the negative value. Okay, so here you can compare of any cell. How to calculate cell potential? Standard cell potential. This thing you did in the 11th class also. What is the standard cell potential? Standard reduction potential of cathode minus standard reduction potential of anode. Correct? This is the easiest way to do this. Otherwise, if you use another method, it will be confusing. Understood? Just take reduction potential always. It will be G. Cathode minus anode. E cathode minus E not anode. Understood?
So this is applicable for both types of cells, sir?
Yeah.
Okay.
Now tell me, Chinmay, if I am taking oxidation potential, how should I write this formula? If I write oxidation potential, standard oxidation potential, what should be the formula?
I'm not sure, sir. I don't.
Standard oxidation potential of anode minus standard oxidation potential of cathode, right? You can make ulta, sign become ulta. Whatever was
Okay,
positive
but
in
because oxidation
reduction,
occurs. Okay, okay. Yes.
exactly. Whatever was positive in reduction, it will be negative in oxidation. Whatever was
Yeah.
negative in oxidation, it will be positive here. Samarth, if I take reduction potential of cathode and oxidation potential of anode, what will be the formula? If you take
Sir, both
standard
should be SRP plus SOP.
of cathode and standard oxidation potential of anode, what should be the sign in between?
Sir, plus, sir.
Plus. Okay. So if you remember three formula, it will be really confusing. Just imagine cathode minus anode. Cathode undergo reduction, reduction have more value, and anode undergo oxidation, oxidation have less value. Even if you see the table, correct? Even if you see table is given in NCERT, no? See, this value is given in the reduction potential. And you know, element that undergo reduction have more positive value and element undergo oxidation have more negative value. Lithium can easily undergo oxidation. So that's why it will have negative value of reduction. It means positive value of oxidation. Makes sense?
Yeah.
This is negative value of reduction, negative value of standard reduction potential. In oxidation, it will be plus 3.05 standard oxidation potential. Makes sense? So usually
Yeah.
we take table in the reduction potential. And that's why reduction value are positive and oxidation value are negative. By the way, you will never do mistake, guys. Here. Never. Why? Why you will never do mistake here?
Sir, for galvanic cell, E0 should be positive.
Exactly. For galvanic cell, E naught should be positive. So whatever you do, value should be positive. Correct? Whatever you do, value should be positive. Even if you make mistake and you make it ulta, if you get negative value, it is wrong.
Yeah.
Make sense?
Yes, sir.
Now we can Now you can see the oxidizing power and reducing power. What is the oxidizing power? Chinmay, reducing power.
Oxidizing power, sir.
Yes.
Uh, Sir, we can tell tendency to accept electrons, like which can oxidize
Tendency
other.
to yes, it oxidize other itself undergo
Reduction.
Reduction.
reduction. So here we'll talk about standard reduction potential. And because it can reduce easily, it means its oxidation potential will be very less. Correct? If element have very high reducing power, means standard oxidizing potential will be high and reduction will be low. Make sense? So whichever element undergo oxidation, it cause reduction of other. That's why it is reducing agent. Make sense? Whichever undergo oxidation, it cause reduction of other. That's why. Yes. Second, Samar, how reactivity of metal is decided? Like which metal is more reactive?
Sir, which can form ions faster.
Which can form ion faster. So oxidation potential or reduction potential? It will depend upon.
Oxidation potential, sir. It should get oxidized fast.
Yes. Example, lithium can easily get oxidized. Like it undergo oxidation very easily, right? So it is more reactive. And element like gold, platinum, they are present below in the table in reduction potential, very low. Correct? If their value is present below and their reduction potential is very high, what does it mean? They are less reactive. Correct? It means they are less reactive. That's why gold are present below, they are less reactive, present almost freely in nature. But if you see lithium, never form uh, pure nature, pure form, right?
Yeah.
In case of non-metal reactivity, Chinmay, just write this is opposite to the non-metal reactivity.
Yeah,
If
sir.
metal
It's
is not, if metal is more reactive, non-metal will be less reactive. In periodic table down the group, if metallic character is increasing, non-metallic character decreasing, right? How to decide Samarth ki which element will be displaced in the solution?
So the more reactive element will reduce. So it should have higher oxidizing potential.
So more reactive element displace less reactive element in the solution, right?
Yeah.
Displace less reactive element or metal. More reactive metal can displace less reactive metal. Example, if you take zinc and copper. Zinc can replace copper, but copper can never replace zinc. Why? Because zinc can undergo oxidation easily, and copper cannot. So whichever element undergo oxidation easily is more reactive, right? More reactive metal. Makes sense? So more reactive metal can easily replace less reactive metal. What are the metal that can produce hydrogen?
Sir, I have one doubt. The SRP value of Zn is more than Cu. That also could be a reason, sir.
SRP value of Zn is low than copper.
That's
Copper have
SRP. Uh,
yes reduction potential. What is the copper value? 0.34 volt.
Yeah, sir. Yeah, sir.
What is zinc value? Minus 0.76 volt.
176. Yeah, sir. Yeah, sir.
SRP, right? Reduction potential.
Sir,
That's
one
why.
Okay, sir.
one question.
Yes, Samarth.
Sir, if SOP is more, it gets oxidized even easily.
SOP is more and oxidized easily. Yes.
Sir, so lithium should have the highest SOP.
Lithium have highest standard oxidation potential. Yes, that's true.
Okay. And least SRP, sir. Negative of that.
Yes, least SRP, because whichever element have maximum SOP, minimum SRP, because negative sign.
Mm-hmm.
That's why we discussed here. Na? Here, for this lithium, SRP value is minimum, but SOP value is maximum. Only sign will change. Value remains same, magnitude wise. Understood?
Yes, sir.
And so, which element can easily produce hydrogen gas and or replace hydrogen? Element have less SRP than hydrogen. They it can replace hydrogen, right? Example, if you say zinc value is minus 0.76 volt, and hydrogen 0. So what will happen? It can easily release hydrogen gas. Same method like this. Whichever element have more SOP, they are more reactive. Less SRP, more reactive, right? Makes sense? Same logic here.
Okay.
Zinc, if you see, have minus value, hydrogen have 0 value, so zinc have more SOP and more reactive. Because this is given in the redox chapter also and here also. And trust me, when they will give multiple element, na, you will be confused. In that case, you need two things. One, reactivity series. And second, how to correlate them with SOP and SRP. You will be confused in both. To make it easy, always take one form. I prefer SRP. Always take only SRP. And remember ki SOP is ulta of this. Okay, example, when I wrote here 0.34 volt, I took SRP here, right? Reduction potential. I took SRP here, reduction potential. That's why it became easy to do. Okay. Now we are done with the most of the thing. Next part is Nernst equation, and at least we'll solve 5-7 questions. One from this, and second from the electrolysis part, because electrolysis part look confusing. And tomorrow we'll finish this chapter. Okay, completely.
Okay, sir. Yeah.
Because basic part is done. Two main part is left. One is electrolysis. Because in electrolysis you have 4 example only. NaCl in solution, NaCl in molten state, right? H2SO4 in different situation. So you have only 4 example in electrolysis, and Nernst equation is where you might face issue. Other than that, the next class will not take more than just take more than 1.5 hours. But we need questions, so that's why half an hour for question, and then everything will be sorted. Understood?
Yeah.
So today was the more basic part, and tomorrow I'll be fast. Read this, and tomorrow I'll tell you, okay, this is SOP, this is SRP, this is how it happened. Cinema, what did you miss before Kolar Club, right?
No, sir, I actually could hear, but I could not speak.
Okay, you could hear, but you could not speak.
Yeah, sir.
Then good. So, Samarth, now you ask me your doubt you had from this current topic, whatever we did so far.
Uh, sir, not much, sir. Sir, regarding potential, sir, is the potential difference between oxidized state, like SOP, if we consider,
Uh,
it is the potential difference between final oxidized stage and initial neutral stage, right?
Potential difference. Yeah,
Sir, so if there is more potential difference, it has released more energy and become more stable.
if there is a more potential difference, more potential energy, then less stable.
Sir, is it released potential energy or gained potential energy?
Gain, na?
Okay.
It depends. If, example, you are removing electron,
Yeah.
there is a oxidation potential. You are removing electron, loss of electron. You
Yeah.
need energy in that case.
Okay. We supplied energy. Okay, sir.
Yeah, you have to supply energy, right? So it is not feasible. But
Mm.
in case of reduction, what happens? We are gaining electron. And in case of gain of electron, what will happen?
Energy is released.
Energy is released. And after releasing energy, it will become more stable.
Okay. Sir, so if more SOP is there, oxidized state would be less stable, right?
If standard reduction potential, oxidation potential is more,
Yeah.
reduction is less. Okay, what is your question?
So oxidized state should be less stable. So
Yeah, the thing is, examples based on the stability, you can say, example, gold, silver, platinum. These are present in the reducing state. They can easily reduce.
okay.
And when they can easily reduce, what does it mean? They can easily convert into their free
Neutral
state,
state.
right?
Yeah.
Neutral state. Neutral
Yes.
state is more stable.
Yeah.
But elements that undergo oxidation, they are less stable.
Hmm.
Make sense?
Yeah, sir.
Neutral state is more stable. That's why compared to Ag positive, Ag is more stable.
Okay.
But
Sir, so,
co- uh,
so more reactive elements will have high SOP and less stable oxidized state.
more reactive element have more SOP. That's true. And less stability. Yes, correct.
Oh, okay, then I got my doubt. So less stable oxidized state
Sir,
is
it is
like,
more reactive. That's why is it less stable?
Yes, anyway, come again.
Sir, it's more reactive. That's why is it less
Yes,
stable?
anything is more reactive is less stable.
okay.
Okay.
Example, if you are more reactive, impulsive, so person is less stable. If you are more calm and composed, then you are more stable.
Okay, sir.
Make sense? More
Yeah.
reactive thing is always less stable.
Okay.
And
So more
when we
reactive will be
mention the reactivity, na, we are indirectly telling about the stability.
Hmm. So
yes.
most
So more
reactive is
SOP.
least stable, sir.
Yes. Yes.
Most reactive is less stable. Yes, correct.
Okay, sir. Yeah.
Any doubts in me?
No, sir.
No, sir. Sir, understood.
Yeah.
Everything is done.
Yeah.
But I will advise you, and you also send me, solve 30 questions from this. Any of your choice,
Okay,
based
sir.
on your understanding. Solve 30 questions. Write in the rough work in your own way. I'm not asking you proper notes. No, in your own way. Send me. Because through 30 questions, you will get your idea where you are facing issue. Because both of you are not extremely good in it.
Yeah.
Maybe you are not bad, but not extremely good. Through 30 questions, you will get each and every idea.
Okay.
Okay, sir.
Okay, so 30 questions today in the rough work. And after that, you send me, sir, those are the questions where I didn't understand well. Please explain this. Because tomorrow, at any cost, I will finish the chapter. Understood?
Okay.
Okay, sir.
Yeah, sir.
Yeah.
Okay.
Okay, guys. Then.
Okay, sir.
Okay, sir. Thank you, sir.
Thank you, sir.
Okay. Okay.